Hi, ladies. I wanted to start out the year with talking to you about matter, which I'm sure you have heard the term matter before, and the different ways that we classify matter and some of the changes that matter undergoes. So, hopefully, most of this is just a review. So, here we go. Okay, so what is chemistry? So, chemistry is the study of the composition of matter and the changes that matter undergoes. So, anything that has mass and occupies space falls under the category of matter. And because of that, chemistry affects all aspects of life and most natural events. So, chemistry is happening all around you, inside your body, every second of the day. Okay, so sort of the first way that we classify matter are the different states of matter. And hopefully, again, you have heard this from a very early age, right? The states of matter are solid, liquid, and gas. So solids have a definite shape and volume, and the shape and volume don't change depending on the container that you put them in. So the particles are tightly packed. And they're incompressible. So nothing that you can do by applying pressure to the solid could make it sort of change its volume. Liquids, right? The particles are close together, but not so close together and so rigid that they can't flow from one container to another. So liquids do have a fixed volume. So if you have 30 milliliters in this container, you're going to have 30 milliliters in this container, but the liquids can change shape depending on the container that you put them in. And then gases can expand to fill a container. So gases don't have a fixed volume or a fixed shape, right? Their particles are spread as far apart as possible. They have tons of kinetic energy, constant motion, and gases are compressible, right? So think about being able to squeeze a balloon. You can squeeze that balloon down because there's so much space between those gas molecules that you can actually, with some pressure, push them closer together. Okay. So another way that we identify our substances is by properties. So there are physical properties and there are chemical properties. So physical properties can be measured without actually changing the substance. Chemical properties, right? The only way you can observe chemical properties is if a substance is undergoing a chemical change, and that means that the substance would have to change. Okay, so some examples of physical properties are hardness, color, conductivity, right? Do they conduct electricity? Are they malleable? What's the melting point or the boiling point of the substance? So those are all examples of physical properties. And then physical properties can be further classified by being extensive or intensive. So extensive properties depend on the amount of matter. So the type of matter doesn't really matter. So things like mass and volume. And then intensive properties depend on the type of matter. So those would be density, color, smell, even conductivity, malleability. Most of these things above in the above cited examples would be intensive. Okay. All right. So what's the difference between a physical and chemical change? So a physical change, some properties of the substance will change, but the composition of the substance will not. So for instance, if you melt an ice cube, right, you're starting with solid H2O and you're ending with liquid H2O, but you still have H2O. Breaking a stick, right, you're going to make it look different, but a stick is a stick. Now, a chemical change is a little different. So this is when we're actually talking about a chemical reaction and the composition of matter does change. So let's say we burn a stick. So anytime you hear the word burning, you're talking about a chemical change. So if you burn a stick, right, you start with a stick and then you kind of end up with that soot, that ash, and that is a completely different substance. So in a chemical change, which is basically what we're going to be studying all year, the composition of matter does change. A new substance is formed, and we do call those chemical reactions. Okay, so how do we recognize chemical change? What are some signs, right, when we're doing labs? What are some signs that a chemical change is occurring? So the first would be a transfer of energy. So does the reaction give off heat? Does it take in heat? Does it give off light? That shows that we have an energy change going on. Second, is there a distinct change in color? Third, production of a gas. So do we see bubbles coming up out of our mixture? And then lastly, the formation of a precipitate. So if we mix two solutions together, do we all of a sudden see a solid kind of form and fall to the bottom of the container? That's what we call a precipitate. So think of precipitation, because when it's falling down, it kind of looks like snow falling or colorful snow. And that's where that word precipitate or precipitation comes from. Okay, so those are our signs of chemical changes. Those are important to remember. So make sure you have those in your notes, put a nice box around them, highlight them, stars, whatever you can do to let yourself know that those are important to remember. All right, so this video, we're actually going to play this, and you guys are going to write in your notes, and we're going to review this, what signs of a chemical change you recognize. So let's take a look.
In this chapter, we are going to explore the difference between physical properties and chemical properties of substances. If we observe the magnesium metal ribbon that we have, we'll look at some of the physical properties first. We first see that it is a solid at room temperature, that it's a shiny metal, that it conducts electricity. Those are some of its important physical properties. At room temperature, the magnesium does not react very rapidly with the oxygen in the air. If we bring in a little bit of heat, the magnesium rapidly reacts with the oxygen in the air. The reaction is very exothermic, as you can see from the light emitted. The white smoke is actually very finely divided magnesium oxide. What we're left with is the ionic compound, magnesium oxide, which is a white solid. Unlike the flexible metal, the ionic compound is a very brittle white solid. So we've lost the properties of the...
Okay, so what I would like you to do is write down at least 2 signs of a chemical change that you saw happen in that short video. And we'll review that when I see you guys in person. All right, so chemical reactions. This is just a brief introduction. We have an entire chapter that we're going to spend on chemical reactions, but just so that you know, in a chemical reaction, a new substance is formed. This should be an arrow here. We go from reactants to products. So on the left-hand side of the arrow are the reactants. On the right-hand side of the arrow are the products. Those are the things that we're producing. And then this is how it would look with the actual chemical substances written into the equation. So we have H2 and O2, so that's hydrogen gas and oxygen gas. That's what the little g's stand for, state of matter. Then you would have an arrow here, and that would produce H2O, liquid water. So that's an O. Okay, so that's what an actual chemical equation would look like. Okay, so conservation of mass, this is a very important piece. So mass is always conserved during any chemical reaction. Okay, so the mass of the reactants must equal the mass of products, and it's based on this law here, the law of conservation of mass. So mass or matter is neither created nor destroyed, it is only rearranged. Okay, so whatever atoms of elements you have on the reactant side of the product, or on the reactant side of the equation, they also have to be there on the product side of the equation. They've just been rearranged into new substances. Okay, so this gets us into pure substances versus mixtures, another way to classify matter, right? So matter can be broken down into pure substances. So in those pure substances, we have either elements or compounds. And if you look at these samples, right, these little particle samples here, you'll notice that there's only one type of particle Okay, particle is anything sort of that's connected into this, into one piece, right? So in the elements, you only see only one type of atom, but in the compounds, right, these are still all identical particles. They just happen to be elements that are combined into a compound. But both samples, what they have in common is that you only see one type of particle, okay, nothing mixed in. So this is a pure sample of, let's say, carbon atoms, and then this is a pure sample of, let's say, H2O molecules. Okay, so those are our pure substances. And then on the other side of the coin, we have mixtures, so mixtures of matters, and that can be broken down into homogeneous or heterogeneous mixtures. So homogeneous mixtures is when you don't see any distinct phases, right? It just looks like one solution. And then the heterogeneous mixtures, you would see what looks to be different parts or different pieces of the mixture. Okay, so a homogeneous mixture, real life, maybe you're looking at, you made some Country Time lemonade. Okay, and if you look in that glass of lemonade, right, it all looks like one nice, consistent substance throughout. In a heterogeneous mixture, let's say you made a bowl of Cheerios with milk, right? You can distinctly see the Cheerios and the milk, right? These distinctly visible parts. All right, so our pure substances that we just talked about, we have our elements and we have our compounds, right? Compounds are a substance that contain two or more elements, and those are combined in fixed proportion. Compounds can be broken down into simpler substances, right? But that would require a chemical change. Elements cannot be broken down into simpler substances. All right, so again, elements versus compounds, right? We contain only one kind of atom. So we have helium, and sometimes these are called diatomic molecules. Oxygen is one of those. It only exists when it's attached to another atom of itself, but this is still only one type of atom. And then compounds contain two or more kinds of atoms. So like the water molecule here, we have some hydrogens and we have an oxygen. All right, so mixtures, a physical blend of two or more substances. Most samples of matter are mixtures. Okay, so there are more mixtures out there existing in the real world than there are pure substances. And again, the difference between heterogeneous and homogeneous. And another word that we use for homogeneous mixture is a solution. Okay, so if you look at the difference here between homogeneous mixtures, you kind of see that you have this uniform distribution of particles, and then heterogeneous, it's non-uniform, and you would be able, just by observation, you would be able to see distinct phases or distinct separation of those types of matter in the mixture. All right, so last piece of this today, of this video, we're going to talk about how we separate mixtures, and it all depends on the type. So the first would be filtration. So filtration is used for separating heterogeneous mixtures. So you can separate the solid from a liquid, and I'm going to show you pictures of each of these too. Distillation is used to separate the components of a homogeneous mixture, and that uses the different boiling points of the two substances that are in the mixture, right? So you heat it, and then the thing with the lower boiling point would boil off first and be separated into a different flask, and I'll show you that makes a lot more sense when you see the picture. And then chromatography, right, is how you separate the components of a homogeneous mixture when they have more similar boiling points. So both distillation and chromatography are used to separate homogeneous mixtures. Distillation, however, can only be used when the components have a difference of a 10-degree boiling point. So you need more of a boiling point difference in order to use distillation. All right, so here is a picture of a filtration apparatus, right? You have a funnel, and then in that funnel you have filter paper, and then you just take your mixture and you pour it through the funnel, and what happens is the liquid portion of the mixture would go straight through, and then the solid particles would actually collect in that filter paper. So that's kind of a low-tech method, and that's the nice thing about those heterogeneous mixtures. They're pretty easy to separate. All right, so here would be your distillation apparatus, and again, this would be a homogeneous mixture where the two substances in the mixture have boiling points that have a greater than 10-degree difference, right? So this would be your original mixture here, and you heat it. The substance in that mixture with the lower boiling point, right, would evaporate. So you see that vapor, and that would come up here. And then it would come down through this condensing tube. Okay, and then it would cool as it's going down the condensing tube. And then that first substance would come and it would collect into the receiving flask here, right? And then the substance with the greater boiling point would be left behind in this distilling flask. So a little more high tech than the filtration. Distillation is actually a pretty cool process to do. Okay, and then lastly, chromatography. Most students have done chromatography at some point in grade school or middle school, and basically you just use some chromatography paper and a plate. You put a sample of the mixture on that chromatography plate in a solvent. Usually it's just water, but sometimes different solvents are used depending on the substance, right? And then those two components kind of would move up the plate, and they would separate, and that would be kind of based on, you know, their molecular mass, and you would be able to see different spots. Generally, the chromatography that has been done, you can do it with ink from a black Sharpie. So black Sharpie ink is actually a mixture, and it works really well with separating using chromatography. So that would be it really for talking about an introduction to classification of matter, properties, changes, and mixtures versus pure substances. So if you have any questions about anything that we've talked about, go ahead and write it in your notes, and we can review that when we're in person. So thanks a lot.